talking about properties of rectangles. Now, rectangles are quadrilaterals, so they are parallelograms, so they have all the properties of parallelograms. Remember, quadrilateral just means they have 4 sides, and parallelograms means that opposite sides are parallel and opposite sides are going to be congruent, opposite angles are congruent, and consecutive angles are supplementary. The diagonals bisect each other, all that good stuff that we talked about last class, plus these 2 additional properties today. All angles are congruent. Specifically, they're going to be 90-degree angles. So in the corners, we will have 90-degree angles. And so that makes all 4 of the angles congruent because they're all 90 degrees, okay? And the diagonals are congruent, okay? So let's take a look at what that means. I've got 2 rectangles drawn below here so we can kind of put these properties drawn in there just as visual reminders. So all of the angles are congruent. They're all 90 degrees. So they're all right angles, okay? We still know, because they are parallelograms, that opposite sides are congruent. And we know that opposite sides are parallel. So these 2 are parallel and those 2 are parallel. Okay, remember we do our little arrows to show parallel. We already knew from parallelograms that the diagonals bisect each other. And because we added the new property today with rectangles, that the diagonals are congruent, if those 2 congruent diagonals bisect each other, then that means that they split into 4 equal parts. Because each of the diagonals got split in half and they were the same size to begin with, all 4 of those little pieces are the same size, okay? All right, so let's put this to play in some practice problems. Now, we are working today, so we are going to put all this together to figure out all these missing parts. Take a deep breath, buckle in, and let's just figure out what we know. So the first thing I want to mark is that I know that these are all right angles because this is a rectangle, okay? And I'm just going to figure out everything I can, just kind of starting and seeing what we know. Okay, so if that's 27 degrees and this together makes a right angle, I know that 90 minus that 27 will be that other part. So 90 minus 27 is 63 degrees. So these little parts, and I'll switch colors, are going to be 63 degrees. Okay, now remember we said that we know that opposite sides are parallel. And so we tell you to look for those Z's. So if I look for my Z's, I've got parallel line, transversal, parallel line. And the reason we say to look for the Z's is because in the crooks of those corners, we know that those alternate interior angles are congruent. So here specifically, I know this angle is congruent to this angle. So those are both 27 degrees. And can you see another Z? If we look, we also know that these 2 sides are parallel. And so if you look for that Z, parallel line, transversal, parallel line, then that means that these 2 angles are congruent because they are alternate interior angles. So this is also 63 degrees. Okay, so that's pretty helpful, and we now have 4 of the angles. Let's see what they asked us for and if we need to figure out more. So they want the measure of angle MJK. Well, the measure of angle MJK is just that big right angle in the corner, so we know that's 90 degrees. They want the measure of MJL. That's that purple angle we just found that is 63 degrees. Okay, they want the measure of angle KML. Now, we haven't found KML yet, so let's work on figuring out how we can figure out what the measure of angle KML is. Okay, so remember, because this is a rectangle, the diagonals are congruent and they bisect each other. So they break into 4 congruent parts. So this side is congruent to that side, which is congruent to that side, which is congruent to that side. Okay, now if we zoom in on this triangle at the bottom that we're looking at, focus on just this triangle here at the bottom, because we're trying to figure out the measure of angle KML that's down here on the bottom. Well, if we're looking at this little yellow triangle, we can see that it's an isosceles triangle. Notice that the 2 legs are congruent. Now, it's been a while since we've talked about isosceles triangles. What do we remember about isosceles triangles? If the legs are congruent, then the angles opposite of them are also congruent. We say if the legs are congruent, then base angles are congruent, which means this is also 27 degrees. Okay, and while we're figuring that out, if we looked at that top triangle, okay, we looked at that top triangle, that's also an isosceles triangle, and so its base angles would be congruent, so that would also be 27 degrees. Okay, similarly, if we want to focus on the triangles on the side, if we looked at these side triangles, those are isosceles triangles, which means their base angles would be congruent. So this would also be 63 degrees. Same thing on the other side. If we looked at that triangle, it's also an isosceles triangle, so its base angles would be congruent. So that would also be 63 degrees. Okay, so let's see if we can fill in more of these missing angles. They wanted to know the measure of angle JLK, so J to L to K, that's that purple angle here. So that's also 63 degrees. They want the measure of angle KML. We said that's our little 27 degrees there at the bottom. And they want the measure of angle MNL. Now, we haven't found the measure of angle MNL. If we want to focus again, that's looking at this bottom small triangle, okay? And we want angle MNL, so we want that top angle. Okay, well, we know all triangles sum to 180, so we can just use triangle sum theorem to help us figure this one out. So if we do, let me see, 180, woo! Let's make sure that's a pen. 180 minus 27 minus 27, we'll get that leaves 126 degrees left for that central angle. So that's going to be 126 degrees. Now that's the last angle they asked for here. Just a little bonus there. We know that those are vertical angles, so this would also be 126. And if you wanted to be a superstar, could you tell me what these angles, and I need to change that mark so that it's different than the other angles. Can you tell me what those angles right there would be? Well, we know that 126 and that missing angle would make a linear pair, so 180 minus that would be 54 degrees. So both of these angles would be 54 degrees, not only because they're both linear pairs, but then they're also vertical angles. So those would both be 54. Now we found every angle under the sun in that rectangle. Whew, I told you we were working today. All right, now we get to do the same kind of thing with the sides. We get to figure out everything we know about the sides. So let's take a look at what we remember. We know that for all parallelograms, opposite sides are congruent. So if this side's 27, so is this side. Okay, and we know that because this is a rectangle, I'm going to mark it as a rectangle, so all 4 of our angles are congruent and they're all 90 degrees. They're all right angles, 4 right angles. Okay, then we know that the diagonals are congruent, and for all parallelograms, diagonals bisect each other, so these 2 congruent diagonals get bisected by each other and they split into 4 congruent parts. So all 4 of those little pieces are congruent. So if I know that one little piece is 15, then that means this piece is also 15, and these 2 pieces are also 15. So that's really a lot of information fast when we know it's a rectangle, okay? And so let's see what they want to know and what we have already. So they want the measure of AC. Well, AC is just this whole diagonal, and it's just made up of those 2 little parts. So 15 plus 15 is 30 for that whole diagonal. Okay, so that'll be 30. They want the measure of BD. That's just the other diagonal. It's also 15 plus 15, or 30. The measure of BE is just one of those little pieces. We said all 4 of those little pieces are 15 because they get split in 4 equal parts. The measure of AB at the top, we already figured out that that was 27. And the measure of BC, okay, now BC we don't have yet. If they want BC, this little part here, okay, then what I want us to do is I want us to take a look at this right triangle. Okay, and I'm going to pull it out of the picture. I think it'll be easier for us if we pull it out of the picture and look at it. So I'm going to draw it here at the top. Okay, so this is triangle DBC. And we already know that this bottom side is 27. We know that it's a right angle. And we know that that entire diagonal from B to D, because it was made up of 2 of those 15s, is 30 units altogether. Okay, and we want to find this other missing side. Can you see by just pulling that out of the picture how easy it is to tell what we need to do? This, if we know 2 sides of a right triangle, we can always find the 3rd side with Pythagorean theorem. So let's give it a go. We know that x squared plus 27 squared equals 30 squared. So that's going to give me x squared plus 27 squared is going to be 729. 30 squared is 900. I'm going to subtract 729 from both sides. That gives me x squared equals 171. We undo a square with a square root, so I'm going to take the square root. Anytime we take the square root, we pick up the plus or minus option. We're only interested in positive sides of our rectangle, so we just need to find the square root of 171. So let's give that a try. I'm going to come over here and we want the square root of 171. I'm going to do a prime factorization tree. Now it's not even, so 2 doesn't go into it. Let's check 3. On your calculator, if you do 171 divided by 3, it goes in 57 times. 57 divided by 3 is 19. And 19 is prime. So as soon as the number on the right is prime, we know we're done. We look down the left side and across the bottom. We have a pair of 3s, so we pull the 3 out. The 19 doesn't have a pair, so it stays in the house. So that's going to be 3 root 19 for BC, that missing part. So x equals 3 root 19, and that was the measure of BC. All right, let's try some more problems. Now, that's as hard as it's going to get. Let's try something a little bit easier for a sec. Okay, find the measure of EF. So they want us to find one of these 2 sides. Because I know this is a rectangle, right, I just like to always mark. I know all 4 angles are congruent right angles, okay? But rectangles are also parallelograms, so I know that those opposite sides are congruent. So I know that 3x plus 5 equals 7x minus 39 because opposite sides are congruent. Now we have an easy equation to just solve algebraically. Those 2 sides are equal, so I set them equal to each other in equation. I'll subtract 3x from both sides. That gives me 4x. I'll add 39 to both sides. That gives me 44 equals 4x. Last step, to get the x by itself, I'm going to divide both sides by 4. And that gives me x equals 11. Now be careful before you box that. They wanted the measure of EF. So let's go find that real quickly. The measure of EF, if I look at its expression, is 7x minus 39. So I put a parentheses when I got to the x, and I'm going to substitute in the value for x we just found of 11. So if I do that on my calculator, 7 times 11 is 77 minus 39 is 38. Is that what you got? So 38 equals the measure of EF. And I like to label my answers, and then I'm going to box it. I told you this would be easier. Okay. All right, let's try this next one. It says the measure of VW. Now, first of all, this is a rectangle, so I know that it's got 4 right angles, just marking some important things I know. And I know that the diagonals bisect each other, and because the diagonals are congruent for rectangles, then they split into 4 equal parts. So all 4 of these little parts are congruent. Now, they tell us the measure of VW, one of those little parts, is 9x minus 11. And they tell us that SU, which SU is 2 of these little parts together, is 16x minus 12. Okay, and they want us to find the measure of WT. Notice that WT is just one of these little parts, so the measure of WT is just going to equal 9x minus 11. But we need to solve for x so that we can plug it in and see exactly how big one of those little pieces are. Okay, so WT is just another one of those 4 congruent pieces of the diagonals. So let's see if we can come up with an equation that's true that'll let us solve for x. Well, the first one I think of is that whole diagonal, 16x minus 12, is made up of 2 of the little pieces. In other words, it equals 9x minus 11 plus another 9x minus 11. Okay, and if you wanted to say 2 times 9x minus 11, that would be the same. Okay, so this is my equation that's true. That whole big diagonal is made up of 2 of the little pieces. All right, so I'm going to combine like terms. 9x and 9x gives me 18x. Negative 11 and negative 11 gives me negative 22 equals 16x minus 12. I'm going to gather x's to one side, so I'll subtract 16x from both sides. That gives me 2x equals, I'm going to add 22 to both sides. That gives me 10. Last step, divide both sides by 2. And that gives me x equals 5. Now, we're not finished yet because we're not solving for x. We're looking for the measure of WT. So let's go back up to that. We said that the measure of WT is 9x minus 11. So when I see that x, I'm going to put a parentheses and substitute in the value for x that we just found, which is 5. So that's going to be 9 times 5 is 45, minus 11 will be 34. And that's the measure of WT. So the measure of WT equals 34. Whew, now that may not have seemed easier to you. We are working up in here. We know a lot of things. We've got geometry skills now added to our algebra skills. We put them all together and we can solve hard problems. We're doing great. So let's go revisit 2 more examples like those first 2 that we did, just so we can get a little more practice where we're finding all the sides and all the angles. So let's go try a couple of those. Okay, so in this first one, we're finding all the different angles. So let's think about what we know. That first of all, we know it's a rectangle, so we know all 4 corners are right angles. Okay, then they told us that the measure of angle DAE, this little piece is 52 degrees. And they want us to find all the missing angles. Okay, so this is going to be the same basic approach that we took with the top one, okay, or the first example. I know that 90 minus 52 can give me that remaining little piece. So 90 minus 52 is 38 degrees. So this is 38 degrees. Okay. And now we can think of it a couple different ways. We can look for alternate interior angles, and I should make my pen skinnier so you can see that. We can look for alternate interior angles. So looking for those z's, because we know that these opposite sides are parallel, then if I look at this z, I know that this bottom piece will be 38 degrees. Okay. If I look at the z made with the sides that we have, so if I look, I know that these two sides are also parallel. So if I look at this z, I know that these are alternate interior angles. So those two will be congruent. And then there's lots of different ways we can get the remaining angles. I like the fact that we know that the diagonals are congruent and they bisect each other. So they split into 4 equal parts. And the reason I like that is because now I can look at each individual triangle there. So I can look at this triangle, and it's an isosceles triangle. And if the legs are congruent, then the angles opposite of them are also congruent. So that makes base angles congruent. So this is also 38 degrees. Same thing in that top triangle. It's going to be the same idea. So that's also an isosceles triangle. So my base angles are congruent. So they'll also be 38 degrees. Now if we look at the side triangles, same idea. Those are isosceles triangles, so their base angles are congruent, which means they're both 52 degrees. Same thing on the other side of the rectangle. If we look at that triangle, it's also an isosceles triangle, so base angles are congruent. So it's also 52 degrees. And then while we're there at those individual smaller triangles, they if we wanted to get the remaining angle in those individual triangles, they ask us for the measure of angle DEC, which is here in this bottom triangle, if I highlight that one. Okay, so we're looking at that triangle. So we could do 180 minus 38 minus 38, and we would get that that remaining angle is 104. Okay, so that's 104 degrees. So if I write that in as 104 there, I know its vertical angle is also 104. They don't even ask, but if we want to be superstars in finding the remaining angle, I know that's a linear pair, so that must be 76 degrees. And then its vertical angle would also be 76 degrees. You can check yourself there because 52 plus 52 plus 76 does in fact make 180. Or if you use your exterior angle theorem, that 104 is the exterior angle to the green triangle on the left, so it equals the sum of the two remote interiors. 52 plus 52 makes 104, which is the exterior angle, and that works as well. See, we know so many things, we can put it all together. Now let's fill in the angles that they asked for. They want the measure of angle ADC, so A to D to C is that big right angle in the corner, so that was 90 degrees. They want the measure of angle ABD, A to B to D, so that's that purple angle on the top right, so that's 38 degrees. They want the measure of angle BCA, so that's that blue angle there on the bottom right, and that's 52 degrees. But we just started rocking and knocking out all the little things we needed. We would have had to find all of those to help us find the others, whether it was by using the isosceles triangles or looking for the z's for alternate interior angles, and we can find those all together. Okay, so let's do one more with the sides. I kind of felt like the sides were easier. I'm not sure if you felt that same way. Remember, because it's a rectangle, I know it's got 4 right angles. And because rectangles are parallelograms, we know opposite sides are both congruent and parallel. So if that's 10, this is also 10 because they're congruent. If that one up top is 24, then this one on bottom is also 24. Okay, and then I know that the diagonals are congruent in a rectangle and they bisect each other, which splits this into 4 congruent parts. Okay, so let's see what they asked and what we already know. The measure of QR we already know is 10. The measure of SR we already know is 24. The measure of SQ. Now we don't know SQ, but we're going to find it the same way we did in the second example. If we zoom in on just this triangle that has SQ and then the 2 sides of the rectangle, okay, and I'm going to redraw it here so we can look at it. Okay, then we already know it's a right triangle. This side is 10, this side is 24, and we'd like to find SQ. This is SQR. We'd like to find SQ, so we'd like to know that hypotenuse across from the right angle. Well, that is a right triangle. If we know 2 sides of a right triangle, we can find the 3rd side with Pythagorean theorem. So let's give that a try. So 10 squared plus 24 squared equals c squared. If we do that together on the calculator, 10 squared plus 24 squared is 676 equals c squared. We undo a square with a square root. And anytime we take the square root, we pick up the plus or minus option. We know we're only interested in positive options, so I'll throw out that other one. So we just need to simplify under the radical, 676. It's even, so I'll divide it by 2. 2 goes into 676 338 times. You can just divide on your calculator. It's still even, so 2 goes in again, and 2 goes in 169 times. Now 169 is a perfect square. That's 13 times 13. And as soon as the number on the right is prime, we're done. 13 is prime, so we look down the left side and across the bottom. Got a pair of 2's and a pair of 13's. So I'll bring those both out from under the radical. So c equals 2 times 13 with nothing left under the radical. So c just equals 26. So that 3rd side equals 26. Okay, so SQ is 26 units. It's the whole diagonal altogether. If that whole diagonal is 26, if that whole thing is 26, then what are each of those little parts? Well, if we take that diagonal and bisect it or divide it in 2 equal parts, we'll get that it's 13 units. So each of those little pieces are 13. So that's 13, that's 13, that's 13, and that's 13 for the little pieces. Okay, so they want the measure of PR. That's the other big diagonal. That other big diagonal will also be 26 units. And then QT is one of our little pieces. We said when you would divided the big diagonal in 2, we got that those little pieces were 13 units each. Okay, and that's our examples with rectangles. Boy, are we getting smart. Boy, can we figure out a lot of things. We can if we slow down and we think about everything that we know. Bring any questions you have with you to class tomorrow.